Henk Akkermans here, Supply Chain Dynamics, Chapter 9, Quality Cascade. Sysdea gameplay 4, the flow of quality. The flow of quality is a complex sector in this model, but it's important. The fact that there were quality problems, and we define quality here quite simply as the percentage of orders that actually does not result in rework. There are many definitions of quality, but that's what we use here. So 1 minus quality is the fallout rate or the fail rate. But the problems that occurred with the quality of that order flow really explain to a large extent also the whole tsunami, the whole quality cascade that followed. But it's complex. There's no denying of that. Let's start at the beginning. Let's assume that 80% of the orders that comes in does not have any problems associated with it, so would normally fall straight on through. We can play with that, and we will later on, but like 80%. Okay, that's then the inflow also to provisioning. That's at least one of the inflow of provisioning. There's another one too. Please let me remind you. Where are we? Provisioning here has two inflows. There's the inflow from new sales orders, and there's the inflow from provisioning rework. Those are the two inflows. It also has two outflows. The normal provisioning rate and of course the provisioning failure rate. We have to remember this because we are modeling a co-flow. So we are modeling a certain aspect of the primary flow, which is the quality of those orders that we model in the primary flow. So we have to keep track of what's coming in, what's going out. So two flows are coming in. Flow from incoming new orders and provisioning rework. Two flows are going out. One to the regular state of provisioning, and of course also one from the sorry, and another one from the rework rate. But the rework rate we assume is then at the normal target level. Okay, back to quality. So the new orders come in like with 80% correctness. That's what we say here. Also, we say that for the service order. For provisioning rework rate, the other inflow, we assume it's the average quality in provisioning rework. And the average quality in provisioning rework, we say that's the target quality, but there is a workload effect. And now about workload effect. What's that workload effect then? Well, when things get really busy, people make more mistakes. That's commonly known. And we have this kind of distribution for it. Trying to get the distribution up. Yeah, there we go. If the workload is at around 1, then there is no effect. But if the workload gets really big, then you will see over a while that some 20% more mistakes are being made, and perhaps even more. No, 20%, we end up with 0.8 up here. Now, where do we get workload from? We get workload from the capacity up here. Workload and provisioning rework is the ratio simply of how much capacity you need divided by how much capacity you have available. A simple formula indeed, but a very complex concept. So if there is more capacity you need than you have available, then the workload becomes higher. When the workload becomes higher, the quality of rework coming in becomes lower. And when the workload of orders coming in becomes lower, then of course the average quality going out also becomes lower. What's the average quality in provisioning? That's the total quality in provisioning. That's rather a abstract concept, but if you would take the elevator metaphor, then it's the weight of all the people who step into an elevator combined, divided by the number of people in the elevator. That's the average weight of people in the elevator. So here we've got the average quality in provisioning, and when we have more work in provisioning rework than we actually can deal with, we have dips. We get dips and recoveries in here, and they're small and modest, but as please don't forget, this is the quality cascade. So this quality that comes out of provisioning flows in into the quality in field install. And here we've got the same story. We've got quality, we've got inflow to field install from provisioning and from the tech install rate. And the outflow is from the field install rate and from the fail rate again. So those are two. So again, we model a co-flow of the total quality in field install. And here also we have a rework effect heading on us. There's also a percentage. This also in the end is quality, by the way, also results in a percentage of provisioning that actually succeeds, and that's because we divide it by max quality. Max quality isn't 100%, or perhaps it is in this case, but that gives you the percent of provisioning that actually goes through, the percent of field install that goes through. So back to field install, there is the cascading effect of problems in provisioning coming down, and there are the effects in field install itself of workload effects on as a result of the effect of workload on field install quality here also as a result of workloads, of more demand on the system than the system can handle. So these percentages then go back to the primary flows up here, where the provisioning fail rate depends indeed on the percentage of provisioning pass, and the field install rate depends again on the percentage of initial install pass. So if the quality in field install goes down, then this percentage install will go down. As a result of that, the field install fails will go up. As a result of that, the amount of rework in this stage will go up. As a result of that, the workload in this stage will go up. As a result of that, even more installs will fail. And that's the vicious cycle that many service companies during ramp up end up with. And it's also the cycle that hit KPN in the quality cascade case.